Hello everyone, this is the second video. In today's video I will present Riemann's hypothesis in a play. So when the curtain rises, a group of people enters in gender neutral dresses and wearing masks. It is not clear if they are finite or infinite in number as they continue to enter the stage. Now, here we need to explain what do we mean by these characters. These characters are all theorems in mathematics, and therefore they also call themselves theorems. This group of people is called theorem. So they represent all theorems in mathematics, whether proved or unproved. At time t is equal to 0, they are wearing masks, which means that none of the theorem has proved yet. As soon as the theorem is proved, one of the character unmasked reveals their identity and go and sit in the audience. Now, all of the characters are initially singing that Mr. Monologue is real. Now, who is Mr. Monologue? Mr. Monologue is a character who is super intelligent, more intelligent than any artificial intelligence such as AIs. So now this group of people, what is called theorem, they are very excited and they are celebrating that Mr. Monologue is real. It is not like just a hypothesis. It's not hypothetical, it is real. Now, another group of people enter the stage. This group of people call themselves proof. So they are not wearing masks, they are unmasked. And they say that if Mr. Monologue is real, he must be able to prove RH, where RH means Riemann's hypothesis. So whenever in physics we test our theories. Suppose I make a calculator and I claim that this is something which adds numbers. First I will check the known numbers if it adds it correctly, such as 2 plus 5 is equal to 7. So if I get 7, I can trust that this is a calculator which can be used for addition. Now, since the first group of people who claim that Mr. Monologue is real, they are celebrating the emergence of Mr. Monologue. If it is real, then Mr. Monologue must be able to prove RH. Why? Because RH, or Riemann hypothesis, is an unproved theorem in mathematics, and we want to prove it. If Riemann hypothesis can be proved by Mr. Monologue, we will believe that Mr. Monologue is really real. Okay, thank you. So now when the first group of people, the theorems, enter and they think that Mr. Monologue is real, they leave the stage. And then the second group of people is about proof. You know that in the theorem is stated just in one line. And then the rest is all the proof of the theorem, which may contain lemmas, axioms, or any other thing that can be used to prove the theorem, main theorem. So now since we are in the second character part, the proof part, we want to prove the Riemann hypothesis in a play. Thank you. Now, the proof claim that if Mr. Monologue is real, he must be able to prove RH. I will just simply say RH for Riemann hypothesis to make it more like rhyming. So, but before proving RH, Mr. Monologue must be able to prove that the prime numbers are infinite in number. That is, there are infinitely many prime numbers. However, the infinitude of prime has already been proved by Euclid. So we know that prime numbers are infinitely many. So now at this point I have to mention that Mr. Monologue is actually a collective human being that represent all human beings, live or dead. Now, since the infinitude of prime has already been proved by other human beings before Mr. Monologue or before Riemann hypothesis, it means that Mr. Monologue is partially real. So he is partially real. We have proved that he is partially real. So what does it mean? When we are proving a theorem by mathematical induction, first we check it for n is equal to 1, and then we hypothesize for n is equal to k, and then k plus 1. We want to prove it. So now here, since we proved that Mr. monologue is partially real, this is the n is equal to 1 case for mathematical induction. Okay, so we have proved that n is equal to 1, Mr. monologue is real, the theorem is true for n is equal to 1. Now we have to generalize it for n is greater than 1 or less than 1. Okay, so the next part is I'm going to prove the Riemann hypothesis. Actually, I'm not proving Riemann hypothesis, I'm proving that Mr. monologue is real. Once he is proved to be real, he proves all theorem in mathematics all at once. So because he is very intelligent, the only thing is to prove that he is real. So in order to prove theorem, I write theorem in the form of a poem, right? So I have some special rules for writing a poem. Whenever I write a poem, make sure that a symbol must appear either in the beginning or at the end of a line, and the line must terminate where a symbol appears. So the first line of this poem is, let Mr. Monologue be R. Now R is a symbol which is used for a real number. Since we want to prove that Mr. Monologue is real, we want to show that Mr. Monologue be R, and since R is the symbol which is used at the end, there should be nothing after it. The line has to terminate here. Now in the next line, we prove that x is equal to 1, where x belongs to R. I have to rephrase it. Let Mr. Monologue be real. Let Mr. Monologue be R. And then x is in R. This is the next line, x is in R. We prove that x is equal to 1 because it was partially proved that x is equal to 1 is real. We know that 1 is mapped to P, where P is prime. Again, as I said, whenever I see a symbol P or anything, the line has to terminate there. And then you have to go to the next line, where P is the set of prime. Let this theorem be T. Then T can be proved in n ways. Because whenever we have a theorem, once a theorem is proved, there may be several proofs of the same theorem. So I said that T is a theorem which can be proved in n ways. If n is equal to 0, this means that T is C. What is C? C is a conjecture. It means that the theorem is not proved yet, and it is just a conjecture. If C, where C is a conjecture, if C is false, then n is negative. And if C is true, then n is positive. T is C, since T is the theorem and C is conjecture. So T is C until proven. Once it is proven, n changes from 0 to positive or negative, meaning that if the theorem was proved to be true, it would be positive. And if it proved to be negative, false, it would mean that n is equal to negative. So n is that n which is used in mathematical induction, but here n can be positive, negative, or 0, because I would use a negative number for n if a theorem is proved to be false, and a positive number if a theorem is proved to be true, and 0 if it is not decided whether it is true or false. Now, since n is changing, we know that either n is 0, plus 1, or minus 1, or plus 2, or minus 2, depending on how many proof or disproof does it have. Thus, n is t. What is t? T is time. And so we proved that in the beginning is we said that when the theorem entered on the stage, they were dancing, and they were dancing and singing that Mr. Monologue is real. And each time a theorem was proved, one of the characters removed their mask to reveal their identity, which means that the theorem is proved. And that is a fact that we know about anything, not only mathematics, anything. So generally, Here T is knowledge, and knowledge is, now it depends if knowledge is finite or infinite. It depends on that, whether our knowledge is finite or infinite. But here it is simple to assume that the number of theorems are finitely, infinitely countable. So they're countable. We can count them, the number of theorems in mathematics. Now, since R is unproven yet, n will change to +1 or -1. If we prove that the Riemann hypothesis is false, then n will change from 0 to -1. And if we prove that Riemann hypothesis is true, n will change to +1 or +2, depending on +1 or +2, depending on how many proofs does it have. So what we proved so far, and that's all we wanted to prove, that n is real, where n was one of the numbers for R, and R was used for Mr. Monologue. Thus, Mr. Monologue has been proven to be real. That's all. Thanks so much.